Today we're going to graph systems of inequalities, which means that we're going to be graphing the same type of functions. We're going to deal with the shading, but now that there's more than one graph, we need to figure out where the shadings overlap. So that's going to be the hardest part about this, is where when we graph and we have all these shadings based on the inequalities, where is the one place that we ultimately want to shade? So all of the stuff we've done with inequalities so far, we just continue with these rules. Okay, so when graphing inequalities, we're going to use the graph and shade each individual function just like we've learned. The solution to a system, which again, when we see the word system in math, means there's more than one equation, or in this case, inequality, is where the shaded regions overlap, okay, or where they overlap, excuse me. And I have two different colored pens to kind of help see that, but that'll be the hardest part that we'll need to figure out. A reminder of all the equations we've graphed in this class. Everything is here. This is a really helpful slide for those of you that still might need reminders as to what type of function we're looking at. One thing we'll have to really focus on is identifying, based on the equation, what type of function we see, and thus what shape of the graph we get. So I'm not going to go through these kind of guided examples here, but basically, or I'll just make a quick note here, but we're going to see like two inequalities like this. We're going to put it on one graph, not the separate two. And so when we put it on one graph, if you flip this over, it looks like this. Okay, now what this is showing is there's a ton of shading going on here. Okay, because we were above this line that has the more vertical slope. We were also above this line that had the less vertical slope. And you can see that it kind of divides the graph into four sections. Well, there's shading in 3 out of the 4, but there's only one section that has the overlap of the shading. And that's what we're going to try to find. Okay, so where does this overlap happen at? Now, with these systems, especially with lines, it is possible that we could have two lines that are parallel, and based on where the shading happens, if we're above one of those parallel lines and one below, well, if we try to figure out where they overlap, that may not exist anywhere. Okay, so know that it can also happen where there's no solutions. Because in this system of inequalities, we need to shade the place or the parts of the graphs that make both inequalities true. All right. The next kind of example here is just showing what if we kind of had this overlap between a quadratic inequality and an absolute value inequality. So this is the two separately, and I'm going to come around with our next note sheet. Okay, but again, if we were to take this inequality of the quadratic and the absolute value and we combined them, but here's what the combination looks like. Okay, based on where the graphs intersect and where the shading overlaps, we would say that the solution to this system is where the shaded regions overlap. And so every point in this kind of shaded region here, if we took the x and y coordinates of every point in there and we plot, or if we plugged them into these inequalities, it's going to be true for both of them. So that's what our shading is representing. It's the set of points that make both inequalities true. And thus, that's why we only care about the overlap. Now, again, it's possible if we had an absolute value and a quadratic, or quadratic and quadratic, or absolute value and absolute value, where there may not be any overlaps. Okay, it could be the case where we have a quadratic and an absolute value graph where we shade on the inside of those graphing, or on the inside of those shapes, and thus there's no overlap, and thus this would be a no solution. Okay, so really our possibilities here are the overlap section or the fact that there might be no solution. All right, well, here we go. I think we'll kind of work through today how we have been throughout all these kind of lessons, where I'll do the first kind of graph for us and then have you all do the second one. So to start this, I'm going to do 1 and then 3 and then have you all do 2 and 4. Okay, and then I just ask that we follow along with me and then don't work ahead. I'll give you time to kind of work ahead and try these. All right, the other thing that I'm going to do here is I'm not going to write down quite as much in terms of what helps me to graph. I'm going to identify the function, but then I'm just going to go straight into graphing it, okay? If you're still having trouble with the graphs, we should be in for access time. This is something that we need to kind of address as quickly as possible because we spend a ton of time graphing now. All right, number one, I recognize that this is linear. That is the one thing that I will continue to write down because that now that we have all types of functions in front of us, really easy to mix up our linear functions with absolute values and quadratics, etc. Okay, that is a linear function that is in slope-intercept form. So my starting point here is going to be on the y-axis down at -8. It has a slope of 4, so I'm going to go up 4 and over 1. And then remember from our past couple lessons, we're not just going to connect all of our points right away. We need to pay attention to what this symbol is. Okay, since our inequality symbol is just greater than and doesn't have the or equal to, we're going to connect these with a dashed line. Now remember, if you need to, you can always make a note to me and say, hey, this is dashed, in case you get it's easy to get going pretty quickly and kind of forget about that. So you can always make a note of that. All right, now before I graph the other line, I want to decide where am I going to shade here, what set of points make this inequality true. The points to the left are kind of above the line, or the points to the right are kind of below the line. So here's that testing part that a lot of us are still trying to kind of grasp that idea. So 0, 0, I recognize that it's kind of above and to the left. We're going to test 0, 0 into the inequality and see if it's true or false. Now when I do this, I'm not going to shade right away. Instead, I'm going to use arrows. Okay, so 0, 0, which is an x and a y. So we're seeing if 0 is greater than 4 times 0 minus 8. So is 0 greater than -8? That is true. Now, since that's true, I know that I want to shade this side, but I'm not going to do that yet. Okay, because we're trying to find the overlap, when we just start shading everything, it can be really hard to kind of tell what you're meaning the true kind of overlap section is. So I just use arrows here. Another thing that might help is once we've identified the side that makes this inequality true, we can put some X's on this other side. So we know no matter what, there will be no shading below or to the right of the line that we just graphed here. Now the X's aren't necessary, but it does kind of help me map out, hey, don't shade over there. All right, so now we're going to do the same thing with the next line, and then where we see multiple arrows pointing into the common area is where our shading is going to end up. So the second line here, or second equation, I recognize again as linear. It is in the same form, so slope-intercept. So I'm going to put my y-intercept here at 5, and then a slope of -1/3. So I'm going to go down 1 and right 3. And we're going to keep doing that until it spans the whole graph, or at least close to it. Okay, this time I'm going to connect my points with a solid line, not a dashed line, because of the or equal to with this inequality. Here we don't have, or it's not just greater than, or excuse me, just less than. And so now, here's what I kind of have in mind here. The one section that makes both inequalities true will be either above or below this green line on the left side of the blue line that I just graphed. That's why the arrows are kind of helping me kind of map that out here. Now to decide, once again, we're going to test 0, 0. So I'm testing 0, 0. If it's true, okay, I know I'm going to shade below this green line. If it's false, then I'll shade above it. So let's test 0, 0, just like how we've already been doing. So 0 is it less than or equal? Well, -1/3 times 0 is just 0. So that's 0 is less than 5. This is true. So that means with this green line, we want to shade below it. And so in total, the overlap of the shadings is where I have both arrows pointing in the same direction. Okay, so I've got to be to the left of the blue line and below the green line. Thus, our one shading is this kind of bottom left section here. Okay, and I did not want to be above this line. And that's going to where the X's can kind of help you map that out there. Okay. I lied. I'm going to actually do 2 and then have you all do 3 and 4. So let's walk through number 2 together. I'll see this one more time. And I really think the best way to go about it is treat each line as a separate problem and use those arrows to kind of figure out where to shade and not just shade right off the bat. All right, number 2, 3x minus 6y. That is a linear function. But it's a linear function that's in its standard form. And thus we need to convert it. Okay, so I need to subtract 3x. So minus 3x, minus 3x, making it negative 6y. And again, I don't really care about the inequality symbols, so I'm just going to make it an equal sign. Okay, all the inequality part we'll come back to here in a second. So right now I have that negative 6y is equal to negative 3x plus 18. Then dividing by negative 6, every single piece of this equation needs to get divided. Making the equation y, and then it equals negative 3 divided by negative 6. Remember on the calculator, this is the one thing that I would have you all reduce down. And I'll just continue to show us how to do that. So negative 3 divided by negative 6. It'll give it to me as a decimal when you do the division. But then if you press this button that points in opposite directions, well, it'll take that decimal and convert it into a reduced fraction for us. So tell me that the slope is 1/2. Okay, so this is a 1/2 x. And then 18 divided by negative 6 is negative 3. All right, so I'm going to graph this line where the y-intercept is at negative 3. I've got a slope of 1/2. Tell me to go up 1 and right 2. Could also go down 1 and left 2. And now to deal with the inequality part, I'll come back to where my inequality started, okay, and check what the symbol was. It was less than or equal to, where the equal to part, tell me to connect these in a solid line. And then we need to test and see where to shade. So this time, 0, 0 is above our line. So I'm going to test 0, 0. Giving me 3 times 0 minus 6 times 0 is that less than or equal to 18. Okay, well, all these 3 times 0s and 6 times 0s is just 0. So we get that 0 is less than or equal to 18, which is very true. Since that's true, I know that I'm going to be shading above this green line, and for sure nowhere below it. Okay, and the X's, again, can kind of help our brain remember not to shade that kind of bottom section there. All right, the next one I'm recognizing once again is linear. This time I have a starting point, though, at 2, negative 5. So I need to go right 2 and down 5. Okay, and that's the part that I usually write down for us, okay, where that starting point is. So again, the x is 2, the y, the sign stays the same as negative 5. And I'm recognizing my slope is the same as being 1/2. Okay, so I'm going to go up 1, right 2. 1, right 2. Right there. Up 1, right 2. Or down 1, left 2. And this time, we're going to connect these points in a dashed line. Okay, and whenever we get these lines to be parallel, it's going to work out a little bit odd because if I'm below this blue line, okay, well, that's already a section we know we're not going to shade. Even if I'm above it, there's like a little sliver right here where we already decided that doesn't make the first inequality true. So this could end up being a no solution, or it may just be that the overlapped part is above the first line that we tried here. Again, we need to test 0, 0 and see what happens. So I'm testing 0, 0. Okay, and this is strictly for the blue line here. So I'm saying if 0 is less than 1/2 times 0 minus 2 minus 5. I'm going to go through order of operations on this right side. So 0 minus 2 is negative 2. If I multiply it by 1/2, that's going to give me negative 1. So I have negative 1 minus 5, and thus I'm checking if 0 is less than negative 6. Well, that's false. Right? 0 is not less than negative 6. And so what that's telling me for the blue line is I should be shading the part of it that does not include 0, 0, which is below it. Well, we already identified that we do not want to shade that part in respect to the green line. Okay, so what I'm looking at here is there's no arrows pointing in the same direction, right? They're all pointing in opposite ways. There's no overlap here. So in terms of what set of points, what x and y values make both of these inequalities true, there aren't any. Okay, so in this case, to this system, there's no solutions. There's not a single x and y value that makes both of these inequalities true. Okay. And again, that's only going to happen with lines if they're parallel. All right. I'm going to ask that you all try 3 and 4 on your own or in your groups. Okay, like I've been saying all week, all I ask is that we try right now. Okay, at the very minimum, graph the lines. If you want to wait on the shading and that's the part we listen to, that's fine. But figure out what can you do on your own and where you're getting stuck at. I haven't filled in the shading yet. Instead, I've graphed the lines and then used my arrows to start to figure out where the shading is going to end up here. Okay, and again, let me get all attention up here so that way we're starting to get the hang of this, because this is by far the trickiest lesson of this unit. Okay, so number 3, the lines end up being parallel. This time, though, with the shading, we're below this first line that I did in green, so the one with the y-intercept at 1. The other line, okay, that has a starting point at 6, 6. Ooh, that was a big voice crack right there. Anyway, this second line that has a starting point at 6, 6, okay, that we're going to shade above it. Okay, so this time the parallel lines, they have an overlap in their shadings. The overlap is in between the two lines, and thus that's where we're going to shade. These points between our two lines make both of those inequalities true, and that's what the shading represents. Okay, so when it's no solution, I don't want us to shade. So that way the shading is strictly showing us the solutions here. Right now for number 4. With 4, after I graph my first line, that I need to convert the slope-intercept. And with that slope-intercept, I get a y-intercept at negative 2 and a slope of positive 2/9. So it's a very kind of flat line there. We should be shading above that line. And then with the other line that's in point slope form, that starting point is at 2, 5, and I'm below that line. So the overlap where both my arrows are kind of showing is this kind of left section here. And again, I only want us shading the one part that makes both true. It makes it much easier for me to tell what you're intending the solutions to be. All right. Questions here? Shh. Okay, well, once you have this over, go ahead and, or once you have this done, go and flip this page over. And we'll talk through the nonlinear ones real quick. Yeah. No, you don't need to staple. That's why we use the binder for. Just put one on top of the other. Okay. All right, here we go. Probably just do these last two, and then we'll probably skip the other two because we're going to run out of time. But I do need side conversations to stop. Okay, and give me about 5 more minutes of pretty focused attention here. All right, here we go. Again, the recognition piece is something that's really important. So this time, I see the absolute value brackets telling me this is an absolute value function. So when I graph this, it's going to be a V-shaped. Okay, so the vertex here for the absolute value is at -4, +6. So -4 and then 6. It has a slope of -2, so I'm going to go down 2 and over 1 in both directions. And I'm going to keep doing that. This absolute value graph is going to be connected using dashed line because it does not have the or equal to part. And then before we even worry about the next line, let's figure out if we want to shade the inside of this V or the outside. Now 0, 0, my test point is on the outside. Okay, so if I test 0, 0 and it gives me something that's true, I'll shade the entire outside of this graph. If it's false, I'll do the opposite and shade the inside. So I'm going to test 0, 0. So I'm seeing if 0 is less than -2 times the absolute value of 0 + 4 + 6. And again, just for saving some room here on the right side, I am going to just think about how some of these numbers will work out. When I go through PEMDAS, I'd have to do the parentheses, which are the absolute value brackets. 0 + 4 is 4. The absolute value of 4 is still just 4. So then 4 times -2 is -8. So this is 0 is less than -8 + 6, where -8 + 6 is -2. So 0 is less than -2. That's false. Telling me we don't want to shade the part that includes 0, 0. So in our case here, that's the inside of this V. And I'm going to draw some arrows reminding me to do that. Okay. Hayla, Nico, we need to focus up, please. All right, then the last equation. Okay, I don't see any brackets, any exponents, so this has to be linear. It's a linear line with a y-intercept at -5 and a slope of +2/3. So I'm going to go up 2 and then right 1, 2, 3. Up 2, right 1, 2, 3. While also going down 2 and left 1, 2, 3. Down 2, left 1, 2, 3. Okay, this linear line, we're going to connect all the points using a solid line because it has the or equal to part. And so I'm seeing one of two places we could shade. We could shade the inside of this absolute value graph and above the blue line, or we could kind of shade this bottom section inside the absolute value graph that kind of looks like a triangle. Okay, if we kind of cap it out at the bottom of the graph here. Now again, we need to test 0, 0. So 0 is it greater than or equal to 2/3 times 0 minus 5. Okay, so 2/3 times 0 is 0, where 0 minus 5 is -5. So 0 greater than 95, that is true. And thus I want to shade, compared to the blue line, the part that would include 0, 0, which would be above this line. Right above the blue line is where 0, 0 would end up being. And now the overlapped section with multiple arrows is above the blue line and inside this V here. And again, that's the only place I want us to shade. All right. Any questions here? All right, well, let's do one last graph here. Let's do an absolute value. Let's just do the next one. I don't think it really matters, to be honest. Actually, I lied. Let's do 7. Let's see what happens with 7 here. All right, number 7. This first line is absolute value. Okay, I recognize the absolute value brackets. It's absolute value where the vertex is at 4, 3. It has a slope of -2, telling me to go down 2 and over 1 in both directions. Okay, for this absolute value graph, I'm going to connect the points using a dashed line because it is just less than. And then before we do anything else, let's figure out where to shade. So just like the other absolute value graph we looked at, 0, 0 is on the outside. And so when I test 0, 0, I get 0 is less than -2 times 0 minus 4 plus 3. This is one to be careful with because this absolute value of -4 needs to change to a positive 4. So this is really -2 times a positive 4 plus 3. So that's -8 plus 3, which is -5. So this time it's true. 0 being less than -5. Actually, I lied. That's not true. That's very false. Okay, since it's false, again, we do not like the part of this graph that includes 0, 0, which is the outside of the absolute value function. So instead, we're going to shade on the inside. Okay, at least that's where the overlap could be, but it all depends on what happens with this next graph. And the next equation is a quadratic function that has a vertex at 4, -4. So I'm going to go right 4 and then down 4. And it has an a value of 2. So I'm going to go up 2 over 1. Then that a value gets multiplied by 3. So from those 2 points, I'm going to go up 6 and over 1. So up 1, 2, 3, 4, 5, 6 over 1. And this time I'm going to connect these points to our quadratic graph using a solid line. All right, so this is one that we really want to kind of ignore the first graph that we did here because the shading is going to feel a little bit odd, and trying to figure out where to shade compared to this parabola is going to feel a little bit different here. Okay, so try to kind of ignore what we had already done with the absolute value graph. And let's test 0, 0 and see what happens with where we shade with the blue graph here. So 0 plus 4, is it greater than 2 times 0 minus 4 squared? Well, 0 plus 4 is 4. And then that's 2. And then that's a -4 squared. Anytime we square something, the result's always positive. So that's a positive 16. And then 2 times 16 is 32. So I get 4 is greater than 32, which is false. So here's why I want us to ignore kind of what we had done before. 0, 0 is on the outside of this quadratic graph. Since we got that 0, 0 was false, that means the whole outside of that parabola is not going to make this inequality true. And thus the place we would shade with this quadratic graph is on the inside. Okay, and then the overlap is on the inside of both graphs, which is a small little section that's kind of bounded by the two vertexes. Okay, so just a small little section for what we're shading here. All right, and we're going to actually stop with those two right there.